Okay, so today we're going to be looking at completing the square. Now, completing the square is a method of factorisation. So if we get given a quadratic where we're not considering the constants, so we've got a quadratic in the form x squared plus bx, then we can factorise this into an expression involving square numbers, namely x plus b over 2 squared minus b over 2 squared. So this is going to be a really powerful tool later on how to solve quadratic equations. We can use this to solve them. In this video, we're just going to be looking at some examples of how to use this formula, and it's not really important that you memorize the formula, just how you apply the method. Firstly, I just want to check this formula is correct. So we're going to expand everything out on the right hand side and just compare with the left hand side. So we can write this square bracket here as x plus b over 2 times itself, so times x plus b over 2. And I'm going to leave this term here as it is, so we'll write b over 2 squared. And then now let's expand these brackets out. So what are we going to get? We're going to get x times x, so that's x squared, x times b over 2, x times b over 2, and b over 2 times x, which is the same as x times b over 2. And then we're also going to get b over 2 times b over 2, so b over 2 squared. And then we still have the minus b over 2 squared. And now you can see that the b over 2 squareds cancel out, and we're left with x squared and these two terms here where x plus b over 2 plus x plus b over 2, so we can just collect them, and we're going to get x times b, or b times x. And this does match up with the right hand side, so this is a correct formula. Okay, so now we're going to look at some examples of how to apply this formula. So first off, let's look at x squared plus 8x. And this is exactly in the form that we want, so you can go ahead and plug in the formula. So what we do is we take an x term, we just write x here, and then we look at the coefficient of the x term here, and we divide it by 2. So 8 divided by 2, write that down, that's just 4, and then we square the brackets. And now instead of just memorizing the formula straight away, essentially what this is saying is if we were to expand these brackets out, we have to make sure that these two equations match up. So we have x squared plus x times 4 and 4 times x, so that will give us 8x. But we're also going to get 4 times 4, so we'll get 16, and to counteract that constant, we need to subtract off 16. And then both sides of the equation do match up. So this is the quadratic expression in the completed the square form. Okay, so now let's do another example, and this time it's going to be a quadratic expression involving a constant. So we'll have x squared plus 4x minus 2. And essentially the method is the same, we just consider the x squared plus 4x, complete the square in here, and then just carry on the constant, and then we can deal with that at the end. So what we do is we write just down x, and then we look at the coefficient of the x term, and we divide it by 2, so 4 divided by 2, we add that on, and then we square this. And now, just as before, we have to think about if we were to expand out these brackets, we need to kind of counterbalance the constant. So if we multiply this out, we're going to get 2 squared, but there isn't originally a 2 squared on the left hand side, so we need to subtract 2 squared, which is 4. So this is from the completed the square form, and then we've still got the constant that we can't forget, we just need to subtract 2 on the right hand side as well. And then we can just collect the terms on the right hand side. Have x plus 2 squared minus 4 minus 2 is just minus 6. So this is the completed the square form. Okay, I want to do one final example, and this time we're going to be dealing with a quadratic equation. So the method is exactly the same, we just have an equal sign in the middle. So first off, we want to rearrange everything onto one side, and if we do this, we get 2x squared minus 4x minus 7 equals to 0. And now we have a quadratic expression on the left hand side, and we're just going to complete the form on this. First off, we need to get rid of the coefficient in front. We only really want to deal with a 1 in front of the x squared. So what we're going to do is just divide everything by 2. And we can do this because the right hand side is equal to 0. 0 divided by 2 is just 0. So if we divide by 2, we'll get x squared minus 2x minus 7 over 2. And this equals 0 still. And now we've got this in a form where we can complete the square. So we just write down x, divide 2 of the x coefficient. So minus 2 divided by 2 is minus 1. So this becomes minus 1. We square this, and then we need to subtract off what this number squared would be. So minus 1 times minus 1 gives us plus 1, and we have to subtract off that number. So minus 1, and then we can't forget the constant from before, so we just subtract off 7 over 2 again. This is still equal to 0. I'm not sure if there's still space, so I'm just going to come up here. And then the last step is just to collect the terms. So we still have x minus 1 squared, and then minus 1 minus 7 over 2, that's the same as minus 2 over 2 minus 7 over 2. This is equal to 0, and then this is easier to collect. We just have x minus 1 squared minus, we just add the numerators, we get minus 9 over 2. And this is equal to 0. So this is the complete of the square form of this equation, and in the next video I'm going to show you why this is useful. It'll be a lot easier to solve this equation now.